Now we see the algebra of complex numbers, which is nothing but the how do we perform the four basic operations, that is addition, subtraction, multiplication and division with respect to two complex numbers. So for this, let us consider two complex numbers z1 and z2 given respectively by a1 plus ib1 and a2 plus ib2. Let's consider the addition first, that is, suppose we want to add these two complex numbers, that is z1 plus z2 equal to, now when we look at the complex numbers, here we will first add both the real parts, so therefore we will have a1 plus a2 as the real part of the final answer, and similarly we will then add both the imaginary parts of the original complex number. So from that we will take I common and we have b1 plus b2 in the bracket. So here we see that when we add two complex numbers, the real parts get added as well as the imaginary parts also get added. So the answer of the addition is also obviously some complex number with its own real part and imaginary part. So therefore it follows that instead of addition, if we do the subtraction, then we will have the corresponding subtraction of real parts as well as the subtraction of imaginary parts. So that is about the subtraction. Now if we consider the multiplication of two complex numbers, which is nothing but z1 into z2. So after substituting the individual expressions, we have a1 plus ib1 multiplied by a2 plus ib2. Now here we have to think a bit. Now since the final answer, whatever it may be, is still going to be a complex number, that means it will have some real part and some imaginary part. Now let's ask the question, how shall we get the real part? That is, by which multiplication within these two brackets we will get the real part as the answer. So for that, the first possibility is that if we multiply real part of one number with real part of another number, we are definitely going to get the real part or the real number as the answer. So that means a1, a2 is definitely the real number. Similarly, we observe that if we multiply the imaginary parts of both numbers, we have ib1 into ib2. Now b1 into b2 is no doubt real, but similarly if we multiply I with I, which gives us I square, which in turn is nothing but minus 1, which is also a real number. So therefore as a result we get minus b1 b2 as another product, which is also a real number. So here we see that the real part of the final product can be obtained by multiplying both of the real parts as well as both of the imaginary parts. So this is where we get the real part of the product. Now we have to think about how shall we get the imaginary part. So that means we have I and into bracket we have to decide the expression. Now here it is clear that if we take the real part of one number and multiply it with the imaginary part of another number, we will get finally an imaginary number. So a1 multiplied by ib2 gives us I into a1 b2, and keeping I outside we have a1 b2 in the bracket. Similarly, if we multiply the imaginary part of first and the real part of second, we will have I into a2 b1. So therefore we will have a2 b1 inside the bracket, and that is how it completes the multiplication. So once again we see that the product of two complex numbers is also a complex number. Now let's move ahead and see how to do the division of two complex numbers. Now in case of division we have z1 upon z2, and of course it is assumed that z2 is not equal to 0 because otherwise we won't be able to divide. So once again z1 is nothing but a1 plus ib1 whole divided by a2 plus ib2. Now here in many examples based on the complex numbers, it is very essential to separate the real and imaginary parts, and for that we must make any denominator completely real. So here we see that the denominator is not completely real because it has some imaginary part of ib2. So how do we get rid of the imaginary part but make that denominator as real? Of course, without changing the value. So for that, what do we do is we multiply and divide by the conjugate of the denominator. So that means if we consider the denominator is a2 plus ib2, we know that its conjugate is nothing but a2 minus ib2. So that is what we multiply and divide with. Now the advantage of this particular process is that if we see the denominator now, the product is of the form x plus y into x minus y, which is x square minus y square. So here we have a2 square minus I square b2 square, and in the numerator we have to multiply the two complex numbers, and we know that how to multiply two complex numbers. So to collect the real part in the product, we have the multiplication of two real parts, which is a1 a2, and multiplication of two imaginary parts, which is ib1 into ib2 with minus sign. So minus I square is plus 1, and we have b1 b2 as the remaining portion. So this is our real part in the product, plus imaginary part is nothing but a2 b1 minus a1 b2, as it is evident from the numerator. So therefore it means we have a1 a2 plus b1 b2 plus I into a2 b1 minus a1 b2 whole divided by a2 square, and we know that minus I square will be equal to plus 1. So therefore ultimately we have b2 square as the remaining term in the denominator. So now we see that the denominator is completely real. It is not having any I term in it. So therefore what we can do now is, if we split the fraction, the first part is completely real. So therefore let's call that as, say, p plus I into, if we consider the other part, this is also completely real because it consists of only a's and b's, which themselves are real numbers by the definition. So therefore let's call that other part as q. So therefore ultimately we have p plus iq as the final answer of the required division. So this is how we always perform the division. Whenever there is a division of two complex numbers, we need to make the denominator as completely real by multiplying with the conjugate of the number in the denominator.